Hello students, in this video we will solve problems based on the factor theorem. So our question says determine which of the following polynomials has x plus 1 as a factor, which means that our g of x is actually equal to x plus 1. But if we take g of x equal to 0, it will mean that x plus 1 will become equal to 0, which means if we take 1 on the other side, x will become equal to minus 1, and then this value we need to substitute in the given polynomial, okay, in place of x. And when we put the value of x over here, if we get the polynomial equal to 0, it will mean that g of x is actually a factor of p of x. In other words, that x plus 1 will be a factor of the given polynomial. So in this question we will have g of x common, which will be x plus 1, but our dividend or our polynomial, that is p of x, will keep changing, and we will have to find out whether x plus 1 is actually a factor of p of x or the given polynomial. So let's begin with our first polynomial. So our first question says x cube plus x square plus x plus 1. So this is our p of x. So if our p of x is equal to x cube plus x square plus x plus 1, all we need to show in case of the fact that x plus 1, so that means we can say over here, to show that x plus 1 is a factor of p of x, okay, it is enough to show that p of minus 1 is equal to 0. How p of minus 1? I've just told you we have got x plus 1 that we need to check if it is a factor of this polynomial, and if x of 1, if we take it of equal to g of x, okay, and we put g of x equal to 0, then x plus 1 becomes equal to 0, and 1 when we take on the other side, x becomes equal to minus 1. So all we need to do is put this x equal to minus 1, so that substitute the value of x in with minus 1 in this polynomial, and once we substitute the value of minus 1 in this polynomial, we need to see the value over here. What is the value of this polynomial? If the value of the polynomial comes to equal to 0, that means x plus 1 is a factor of this polynomial. If any other value comes over here apart from 0, that means x plus 1 is not a factor of p of x, which is not a factor of this particular polynomial. So that is all we need to check. So let us substitute minus 1 in this polynomial to check whether we get it equal to 0. So p of minus 1 equal to minus 1 whole cube plus minus 1 whole square plus minus 1 plus 1. So here we get minus 1 whole cube is minus 1 plus minus 1 whole square is plus 1, and plus into minus 1 becomes minus 1 plus 1. So minus 1 plus 1 0, minus 1 plus 1 0. So we get this equal to 0. Therefore we can say that x plus 1 is a factor of p of x, okay, or of this particular polynomial. You can write the whole polynomial as well over here. So we complete this. P of x equal to x cube plus x square plus x plus 1. So this is how we find out whether g of x is actually a factor of p of x. Let's solve the next problem. So here we have x raised to 4 plus x cube plus x square plus x plus 1, okay. Now to prove, we say that p of x, okay, equal to, or you can say let p of x equal to x raised to 4 plus x cube plus x square plus x plus 1, to show that x plus 1 is a factor of p of x equal to x raised to 4 plus x cube plus x square plus x plus 1. Okay, it is sufficient to show that p of minus 1, okay, is equal to 0. Okay, so now again I'm not going to show you how we get p of minus 1 over here. So we just need to show p of minus 1 equal to 0 over here. So let us check what is p of minus 1 in this case. So minus 1 raised to wholes 4 plus minus 1 raised to cube plus minus 1 raised to whole cube, sorry, square, plus minus 1 plus 1. Minus 1 raised to 4 becomes plus 1, minus 1 cube becomes minus 1, plus minus 1 whole square becomes plus 1, and this will become minus 1 and plus 1. So 1 minus 1 is 0, 1 minus 1 is 0, and we are left with plus 1. So which means p of minus 1 is not equal to 0. Okay, so this implies that this implies that x plus 1 is not a factor of p of x equal to x raised to 4 plus x raised to cube plus x raised to x square plus x plus 1. Okay, so this in this problem the given polynomial was not equal to 0. That means the value of the polynomial did not come to 0 when we substituted x equal to minus 1 in this polynomial. Fine. Let's go to the next problem. So the next one is x raised to 4 plus 3x cube plus 3x square plus x plus 1. So you can take let p of x equal to x raised to 4 plus 3x cube plus 3x square plus x plus 1. So you can say to show that p of x equal to x raised to 4 plus 3x cube plus 3x square plus x plus 1. Okay, sorry, cancel this part. To show that x plus 1 is a factor of p of x equal to x raised to 4 plus 3x cube plus 3x square plus x plus 1, it is sufficient to show that p of minus 1 equal to 0. So let's see what is p of minus 1 here. Minus 1 raised to 4 plus 3 into minus 1 raised to 3 plus 3 into minus 1 square plus minus 1 plus 1. Minus 1 raised to 4 comes to plus 1, and minus 1 cube comes to minus 1. Minus 1 into plus 3 gives us minus 3. Minus 1 whole square is plus 1. Plus 1 into plus 3 gives us plus 3. Minus 1 plus 1. So here minus 3 plus 3 gives us 0. Minus 1 plus 1 gives us 0. We are left with 1. That means p of minus 1 is not equal to 0. So this implies that x plus 1 is not a factor of p of x, which is x raised to 4 plus 3x cube plus 3x square plus x plus 1. Right? Let's solve another problem. So our next problem says x cube minus x square minus 2 minus 2 plus root 2 x. This is one whole single term plus root 2. So we need to see if x plus 1 is actually a factor of this. So we'll take let p of x equal to x cube minus x square minus 2 plus root 2, whole thing in brackets, x plus root 2. Okay, and we can say to show that x plus 1 is a factor of p of x equal to x cube minus 2 plus root 2 x plus root 2. Okay. It is enough to show that p of minus 1 is equal to 0. So we will see what is p of minus 1. P of minus 1 equal to minus 1 whole cube minus 1 whole square minus 2 plus root 2 into minus 1 plus root 2. So wherever there is x, I have substituted it with minus 1. Minus 1 whole cube is minus 1. Minus 1 into minus 1 whole square becomes plus 1. So minus 1 plus 1 becomes minus 1. Here it will be minus 2 plus root 2 into minus 1. That will become plus 2 plus root 2 and plus root 2. Okay, so this will become minus 1 become minus 2 plus 2 becomes 0. Root 2 plus root 2, that comes to 2 root 2. So obviously p of minus 1 is not equal to 0. Okay, so this implies that x plus 1 is not a factor of p of x equal to x cube minus x square minus 2 plus root 2 x plus root 2. Okay, so this is how you determine whether a given polynomial, that is g of x, is a factor of the p of x. Okay, so if you've liked this video, please click the like button. Do not forget to share it with your friends. Subscribe to the channel if you haven't done so yet. Do not forget to click on the bell icon. It will help us to notify you when a new video is posted. Thanks for watching. See you in the next video.